Hi, this is Lindsay Savage for Module 5, Lab 5. This one we took Benedict's reagent and we tested it in several different sugars or carbohydrates to see if there were any aldehydes present in those carbohydrates. So if there were, what would happen is the Benedict's reagent has copper in it, so the copper would oxidize the aldehydes and under these acidic conditions, and they would form carboxylic acids in place of the aldehydes, as well as copper precipitate. So the change in color of the solution from blue to anything else is indicative of an aldehyde present and adjacent to a hydroxyl group. And copper is actually the least reactive metal and is therefore going to also be the most selective. Now, sucrose tested negative. It didn't change color at all. It stayed the blue color of the Benedict's reagent. And this means that there's a lack of aldehydes present, or there's no aldehydes present. And it also means that sucrose is a non-reducing sugar or carbohydrate. That means that it won't undergo oxidation. Now, the others, fructose, dextrose, and maltose and lactose, all tested positive, but to varying degrees. So the one that appeared to be the least concentrated to me was lactose. And it's been a couple of days since I actually did the experiment. So these actually, you can see the precipitate a lot better now than you could when I initially wrote up my lab. But you can see the little bits of flecks of I think you can, orangish, brownish in there. And this one had the what looked to me to be the least amount of change, which indicated that there were aldehydes present, however, in lower concentrations. And being that there are aldehydes present in these carbohydrates, that indicates that these are all reducing sugars or reducing carbohydrates. And then I had maltose. And this looks clear, but if I kind of mess with it a little bit, you can see the precipitate go towards the top right there, which, looking at it now after it's been a couple of days, it looks like maybe there's more in the lactose than in the maltose. So that's going to be off a little bit on my lab report. And then I had dextrose, which you can see the color change there. Really nice orange color. See the precipitate that's formed as a byproduct of the oxidation of these sugars. And then we have fructose, which looked to me like it oxidized the most, or it was the highest concentration, because it turned the darkest orange. And yeah, I'd still say that looks to be the darkest, which I thought was interesting, because when I drew the diagrams, it was obvious to me that dextrose, or glucose, was, clearly has aldehyde groups right there present. So I thought that was kind of interesting. But you can see in the fructose too as well. And another thing that I wanted to mention is that if they're reducing sugars, it means that they do oxidize, and it means that there's a presence of hemiacetals as well. So not full acetals, but hemiacetals. And then, let's see, for the mechanism, we can see, okay, so I have the original up at the top. I just made the R group, the whole tail. I didn't want to have to draw it over and over again. And I don't think it's the clearest, maybe. There you go. But so basically, we take this aldehyde and we turn it into a Gibbs diol. So we go through the mechanisms and we end up with two hydroxy groups in a Gibbs diol. And then the copper is the reducing agent, or the oxidizing agent. copper gets reduced. Yeah. And so it's going to attach to one of those oxygens after and kick off the hydrogen. Other hydrogen's going to be pulled off. We're going to create that double bond, and copper's going to be kicked off. And what we're left with is the carboxylic acid, and then the rest of the tail. So the higher concentration, again, the darker the color that the Benedict's reagent turns it. It indicates that it's a reducing sugar, indicates the presence of a hemiacetal, and the lack of reaction or negative, like in sucrose, indicates that this is it has an acetal, it doesn't oxidize, and it's non-reducing. And let's see, I think I covered everything, so sorry for the noises in the background. I got the baby in the rocker. Thank you.